2 book chapters, 27 journal articles, 34 conference articles. He is the senior member of IEEE, also member of International Association of Engineers, that is IAENG, also member of Indian Society of Technical Education, that is ISTE, and also member of India, Institution of Engineer India. So with this, we can start today's schedule. So I request Mulla sir, please start your presentation.
Thank you, Parajit, for giving me this STTP.
Yes, sir. Thank you, sir. Thank you. Thanks for accepting our invitation, sir. So you can share your videos.
Participants share their videos?
No. You just share your videos, sir. They are allowed, but it is their wish. So all participants can start their videos.
Yeah, can you switch on your video for a while? Let us see.
Yes, yes. So I request all participants, please start your video for a moment. Please start your video for 5 minutes only. Then we can start our program. So we're having a faculty members, some industrial persons, and some students also. So first, Mulla sir want to interact you. Then we can start our today's presentation. Please, please, please. Yes. अभी screenshot ले.
Reluctant.
Yes. Please, I request all participants, please start your video for a moment. Then you can switch off your video after 5 minutes. Please.
Hello, Jope sir.
Hey, Jope sir is there. Jope sir. So we can have a one screenshot. We can have a one screenshot. Please start your video.
My purpose is not screenshot. I wish to see to whom I am talking.
Okay.
So, we all teachers are nowadays supposed to teach this online mode. It is very difficult. So, exactly what we have started is there will be 2 monitors. All student will be visible on one screen, and via second screen we present. So that way some interaction between student. So if you ask some question, how they will respond. So video should be on. Via thumb they will say they agree or not agree, etc., etc. But then that problem of data getting exhausted and all that will come. So for be something different, but normally they will also not prefer to continuously keep their video on. Asarji is seen, Gaikwad is seen, Joe sir is there. Is there. Anyway, if you feel free to interrupt me at any point, okay?
Yes.
And normally mic should be mute so that we will not have disturbance. But if you feel ask at some point, given instruction last 15 minutes. If you feel something we should discuss in between, from my side it is open. So today's topic, what I have taken, something very closely related with our farmers. So, educational outcome should come something where government is continuously forcing. It should be useful to the society. With few years back, around 3 years back, one of the student joined for PhD under me, and he said, do something for farmers. And then this topic of pumping. Till that point, I was not knowing farmers' problem and issues with pumping system and all that. Since he was interested, I said, let us study. So I will be presenting today some work I have done for my student, with my student Rajan Wamja, something we have studied together. I will try to present today. And to discuss in Indian context, a very high-end solution, but farmers are struggling even to pay for the electricity bill and how to apply those solutions to society. In that context, we will have to think. So no additional cost it should involve. That way, anything we suggest, that we need to plan. So what I have given is development of grid interactive solar water pump system. This presentation also, Rajan, yesterday he was there. He has helped me to prepare this. So, agenda of this presentation. So what is the motivation of renewable energy study in our engineering education? Renewable, what is the stake of energy? So everything is driven by country's vision. So where our leaders want to take our country, they will frame some policies. So we have a very ambitious target. We have a separate ministry, MNRE, and a very ambitious target of renewable energy. Some figures I copy pasted from MNRE website will be there in slides. And how to align our education system, then the output of our education system, our students, our industries, in order to achieve those targets. The motivation for studying water pumping system, existing solar water pumping system, what are the different configuration, technically what are the plus minus of all those configurations, which configuration will serve the better purpose. So those theoretical detail first we will try to take, and then work what we have done with the student, that I will try to present. Finally, also I spoke something. I have a contradictory view as compared to normal educationalist. I feel that our country need more development than research. We should be able to reproduce something which is existing world over, and our engineers should solve our societal problem utilizing those solutions instead of inventing something new. Including me, full educationalists are trying to do some new research and then publish in international journals. And there will be a very small relation or meaning of those research to our societal problems. So, employability of students are also major issues. College not getting students are also major issues. So not plan properly while increasing number of colleges where the outcome will go. And now there is a scenario where they are struggling in spite of getting good education, they are unemployable. Some views where how engineering is all about doing something. It may So it may not be a very perfect solution, but something we should make working, which will solve some problem. So that way engineering should be taught. So some contradictory view what normal educationalist will not like, that one or two slide I have kept to share with you. We will summarize what all presentation I am making. So this is the agenda for today's presentation. Finally, so what way we thought and we created something, and we feel that it can be applicable to existing solar water pump system. That will be the major technical takeaway from this presentation. So is this okay? Some feedbacks? Not asked.
Okay, sir, it's okay.
We are together for next 2 hours to deliberate around these topics. Okay. It should not be one directional. I encourage ask something, or if you have a better idea, it is not like I am some expert and only can speak. Okay, you can all others. You can also contribute. You can share your views, and all participants will be benefited. So
Yes.
if we start for renewable energy, then NRE website, if you refer, by 2022, India want to achieve 175 gigawatts of electricity by renewable sources. There are separate targets for solar. So major out of 175 gigawatts is targeted via solar energy. We are surrounded by a good oceans, so wind can also be a very good source of generating clean energy. And 10 gigawatts by power and 5 gigawatts for hydropower. So what the target ministry or government is having. As we have witnessed, normally government targets, normally they extend and then after many years it achieves. But surprisingly, this case, it is working in leading. So many of the target they have set, it will be achieved ahead of the time. So that way, country is moving towards renewable sector. Difficulty is of manufacturing capacity is not able to support everything, though we have good concept of making India and all those things. But if somebody will evaluate from where all this hardware have come, what type of inverter from which country we have procured, how they will be maintained. So it is all majority is imported. They might have some subsidiary in India, but ultimately major money of this investment done by the country is going to foreign MNCs. So there is a method of creating a subsidiary company in India. So Siemens India will be there. But if we make accounts of who is investing, so government is investing, from where the money is coming. So our taxpayer money on they are taking, that is the income. And where it will go? So it will go to big MNC players, and Indian industries, very little portion is going out of this. Manufacturing really, we will have to make our country capable, where why we cannot deliver these needs from our side. But it's mentioned at MNRE website that once achieved 175 gigawatts, 100 gigawatts will be targeted in next 5 years, and more approximately 350 gigawatts will be targeted by 2030. At present, if we see our fossil fuel bill is very high, so the amount what we are paid for fossil fuel is quite high. So making this renewable sources capable enough of providing the major portion of our electrical engineering requirement, converting all vehicles from fossil fuel to electrical vehicles, should help us reduce that import bill. That is how we can save that money. Or
Yes, sir. Yes, sir.
Yes, sir.
Okay.
no, some message was there, network problem. So as a country, engineering cannot, as an engineer we cannot skip, and we will have to contribute towards these targets, okay, irrespective of the negative issues what I mentioned. Now, if we have one slide related to solar energy, so solar energy has a potential to fulfill increasing global demand. India is leading. Okay, so our Prime Minister sir has whatever forum he has established. So we are leading. If we make an account of where the electrical energy is getting utilized, so major user of electrical energy is our household demands, industrial demands. Another big area is water discharge system, and third is electrical vehicles. So these are the three places where major use of electricity is there. And in these three places, large part of the energy are getting utilized in electrical machines. So it may be a pump or fan or compressor. That is where electrical energy is converted into some other form, maybe a thermal energy or heat energy or chemical energy, and that is how uh, it is utilized. So major use are at these places. So simple idea is, so suppose water discharge, being an agriculture dominated country, we in one of this article number 3, it is reference is given. So during that survey, 36 million water pumps, it was run either through electricity or remote places where electricity is not available, through diesel. So 1 million is 10 lakhs. So around 2.6 crore water pumps are existing. They are major loads. So simple idea is, if we can transform water pumps to water pump, number one, we will not require electricity, so fuel saving can happen. Transmission losses can also be reduced. Farmer water pumping will be irrespective of power cuts or faults in the grid. The diesel will also decrease, so pollution will also decrease. One idea is how to convert these pumps into solar water pumps. Okay. Solar energy, these are the three places. Our household, we are witnessing, every household there are rooftop panels now, and we are generating electricity. It is going inside the grid and we do not know who is utilizing it. In a situation, if we do not have load at our house, then adjacent houses are utilizing energy generated at our terrace instead of energy coming from far remote places. So these are the
My,
three main area.
I
These are
request,
the
please,
three.
please mute your mic. I request all participants.
All participants keep their mic in a mute mode, and whenever you wish to speak, you can unmute and you can speak.
Okay. Okay. Thank you.
Disturbance will not come.
Oh, sir.
Distributed generation, then I am just giving you a point where we can target. So government is also targeting like this. So every place we have rooftop panel where might happen that our power plant is not required to send electricity. This distributed generation is managing that. Discharge, I see in a big area because so many pumps is where the electricity can be generated. Its need of irrigation can be fulfilled. And better idea is if that generator energy, just like our house, can also be fed back to the grid, then it also contributes towards grid support. And another big area what is coming up. So last budget, if you can recall, our finance minister announced that vehicles will be converted into electrical vehicle, and the deadline is 2030. So mobile sector, there was a major dip. Were started feeling that now this diesel and petrol car has gone and only electrical cars will be there. But they said that it will also be continued and all that, and that is how after a dip once again that sector is picking up. Challenges having electrical vehicles network, fast charging, so there will be an impact consumption of electricity, and many people will be drawing that. So we will have to make our charging infrastructure, our systems, our generators capable enough where many vehicles are taking huge magnitude current in an impact form. They should be able to support. Infrastructure will be a major challenge if we really wish to achieve a pure electrical vehicle. Okay, and our power system should be capable enough where this will happen. If you see developed country, very intelligent way they are utilizing electrical vehicles. So there remains a variable tariff where uh, off-peak period the electricity tariff is very low. Normally they charge all the vehicles during the period where electricity tariff is very low. During the peak period, maybe afternoon 11 o'clock, 12 o'clock, offices are working, factories are working, and there is a huge demand of electricity. So during that period, vehicles are parked in the not utilizing it. So in a developed country, if you refer some magazine articles, so they export energy from vehicle to the grid. This way they earn money via this charging and discharging of so at that advanced stage they are utilizing, so it will also become a source. So will we have bidirectional flow of electrical energy with vehicles if such objective will be there. Okay, but in general these are the three major consumption point of electricity, and introducing solar at all those three places help us to make our power system capable enough for providing uh, better electrical energy to all these loads. Okay. Motivation why solar energy we should study. Coming down to one narrow area of this pumping system. So, MNRE is the reference. MNRE, some report if you refer, the 21 million or 26 million, whatever was mentioned, it is mainly electric and diesel pump. Pumps not only expensive, but it also create air pollution. They have started replacing this with environment-friendly solar water pumps. It's how what progress has happened. If you take some data to between 91 to 2014, so around 15 years, around 11,600 solar water pumps were installed as per MNRE data. And next 0.1 lakhs more solar pumps were installed, and 2019 2.37 lakhs more solar pump the ministry has installed. they are promoting by providing some subsidiary. They are promoting farmers to utilizing solar water pump instead of diesel pump or electric based pump. So once again, there is a target. So by 2022, of India want to install 10 lakhs standalone solar water pumps. Standalone pumps means panel and pump. So if sun is available, some water it can pull. There is a separate target of more 10 lakhs pump where they want to convert existing grid connected pump. So time being we have electrically pumps. So those pumps they want to solarize. There is a separate target of 10 lakh new installation of standalone pump and 10 lakh existing electric pump to be converted into solar water pump by 2022. So this is what government is aiming, and accordingly they are framing their policies, providing subsidiaries, different stakeholder, so that this target can be achieved. So these are some motivation related to Indian context. Now coming down to technical part. So what are the different electrical motors that are explored in pumping application? So in an area where a single phase supply is available, efficient, I must use the word inefficient, single phase induction motor is the solar water pump. Even at our house, when single phase supply is only available, we use a single phase induction motor base to fill overhead water tanks. Most of area where supply is available, our rugged three-phase squirrel cage induction motor based pumps, which are very low cost. Once you install, nothing you have to see. And it will be having a simplicity and high reliability. So major water pumps are made up of our three-phase induction motor. And if you refer the literature, permanent motors are also preferred due to inherent advantage. The advantage of permanent magnet is very high efficiency, compact in design, high torque to inertia ratio, quick deceleration, high flux density, high power factor. So because of these technical results, in research, people have experimented with permanent magnet based motors. Okay. Developed country are in oppose of this, so they are discouraging use of permanent magnet motors, though they are highly efficient, because the supply of permanent magnet practically is limited to one country. So because of those non-technical aspects, they are discouraging the use of permanent magnet motors, that is our brushless DC motor and permanent magnet synchronous motor. If we forget all those aspects and if we focus on technical part, then they are highly efficient. So in one of the study, this paper number 3, the author claimed that compared with the electrical submersible pump, permanent motor at 20% less power compared to, it uses 20% less power as compared to electrical submersible pump, normally utilizing induction motors. So with the advantage of this, the moment we require 20% less electrical energy, because it is a solar water pump, then corresponding PV panels what we require. will be of lesser size. So size of PV panel will reduce if the pump consumption is reduced by 20%. So producing permanent magnet motors will reduce the cost and size of PV panel what we required. And in addition to, it will also improve the performance and it will also be a maintenance free operation. So very popularly used motors are that is permanent magnet synchronous motor, PLDC brushless DC motor. So for pumping application also they are explored. Motors are compact, but are quite costly from agriculture point of view. Good machine switch reluctance motor where permanent magnet will not be there. Reluctance torque based synchronous motor that is also explored for pumping experience. The difficulty with this permanent magnet based motors is their control is quite complex. It requires position sensors and our pump will be somewhere in the ground. So placing such sensor in possible pump is tremendously a difficult task. Applicability of these motors are having these technical challenges. So motor we have three parts. That is core material and insulation. So normal motor to induction motor if we say, then what may make our motor is these three elements: copper, aluminum and insulation. But if you consider these permanent magnet motors, in addition with these, require semiconductor also. So for commutation, we require Hall sensors, then transistor. So whatever commutator and brushes we're doing in DC motor, same thing will be done. Its analogous thing is Hall sensor and transistors. Okay, placing those sensors in a possible form is one side and bringing those terminals because controller will be at the surface and then utilizing that. So these are the issues for applying BLDC or PMSM or SRM motor in pumping applications. If we come down from technical to non-technical thing, who are the suppliers of pumps in India? So these are the big names. SHAKTI pumps. I am sure all of you must have heard. Lupi, then Falcon, as high as 100 HP pump, 50 HP pump, 30 HP pump. They are supplying. The supply is not restricted to India only. They are big exporters of this water pump also. So other countries also are exporting their water pumps. So previous slide discussion to study which motor they use. So it will come down to all of them uses our three-phase squirrel cage induction motors. All the present pump what they are constructing that is utilizing our three-phase induction motor. So these are some data or some information related to the present scenario of pumping in the context. So any thoughts at this instant, or if somebody want to comment, please go ahead.
Do you have any query? Please ask. Any doubt? If you're having any doubt, please you may ask.
Not doubt. Also, if you have some view, feeling like inner feeling, I express that money going outside. Anything you can speak. Okay.
Yes.
Okay, so nobody want to speak.
Nobody want to speak. Okay, sir. Continue, sir. Sir,
So
you may
further,
continue, sir.
I will continue. Next part of presentation, we will try to take the technical details how we can construct solar water pumps. Power electronics interface we require for constructing solar water pumps. Different arrangement, what are their plus minus. So next part of presentation, I will try to brief you about different arrangement for connecting solar panels to water pumps, and then some power electronics interface for controlling that. First simple arrangement is have a solar panel followed by our 3-phase 6 IGBT inverter, and there will be a induction motor. Now this is unlike a normal variable frequency drive. We are having ceiling always available. Output is a function of radiation and temperature at that instant of time. So it's continuously varying. And we have that IV curve of panel, and from IV curve, if you multiply I and V, we can have PV curve of the panel. So we should try to take whatever maximum power we can extract from this panel. So there will be a concept called MPPT, maximum power point tracking. So try to extract whatever maximum power you can. It is the peak of that PV curve. So it is P versus V. So how it can be achieved? So is the panel voltage such that you will be at the peak of that curve. Panel voltage will be adjusted by the effective impedance. This motor and inverter will connect at the terminal of your panel. So we need to change the effective impedance continuously, then we can keep tracking the peak of that curve. Okay. Part that will come is we need to sense voltage, we need to sense panel current. There are, use the word, hundreds of MPPT methods are available. Processing that voltage and current, at what point you should operate so that maximum power you will get, that can be extracted. Okay. Here our load is induction motor. Whatever power is available, power we should give to the motor, and it should convert it into mechanical, and then whatever water discharge it can support with available power, it should do. So whatever end output of MPPT will come from that, we will extract the frequency. What frequency we will run the fan. So if it is very low power, then very low frequency we will run the fan pump. If you are getting good, there exists a good intensity of sun, and you are getting fairly good amount of power, then accordingly the frequency will increase. So pump will be operated at a higher speed. Flow will be more. Now, as you are aware, the practical method of controlling induction motor is V by F control. Frequency, the stator voltage also we will try to correct. And output of MPPT is some frequency which will match motor power and power available by the PV panel. And V by F control we will do via utilizing some modulation technique so that frequency and modulation index will be converted into 6 gate pulses for driving the motor. One arrangement where 6 switches, 6 semiconductor switches in between PV panel and run via this logic will help you to extract maximum power and will help you to run the pump with the available solar energy. power. So the pump equation is torque is proportional to square of the frequency. So accordingly, the power is nothing but torque into speed. So relation between power and frequency is some constant into frequency raised to 3. Cube F is related with P. So by after having MPPT power value, what frequency you will run. So by calculating this pump constant K1, we can convert the available power into the frequency. So pump constant K1 relate of cube root of available power divided by the motor constant, pump constant. That way we can find out at what frequency you will operate the pump. Where this energy will come, so it will come to the electrolyte capacitor connected at the panel output. So this is P versus V curve, and we always want to remain at the peak of this curve. Can be adjusted by having different voltage at the panel terminal. So V at different voltage will be adjusted. So the power is given to the DC link voltage, right, and it will run with the available power. We will calculate what should be the frequency of motor, and V by F control we will apply the motor, and that is how the combined arrangement will work. So if radiation or temperature has changed and different power is available, and then with a different frequency you will operate. Once again it has been modified, then continuously the peak of this power curve we will try to extract. Result into variable frequency operation. So your motor speed is continuously changing. Accordingly, the water discharge rate by this pump will be continuously changing. So based on the available density and temperature, whatever PV power will be available, proportional to that, frequency of inverter will be there, and the speed of the pump will be there, and that is how variable it will result into a variable water discharge via this arrangement. Okay. So this is the first arrangement, 6 switch. The end conclusion is variable frequency, so variable speed of the motor and variable flow rate, variable flow rate of water discharge. So that way you can consider this arrangement. So this is the first arrangement or first power electronics interface. What can vary or what can connect a PV panel to the motor. The problem with first arrangement is the DC link voltage is our panel voltage itself, which we will have to change continuously to a maximum power. Now, the inverter voltage itself is continuously changing, then establishing V by F control will be very difficult. So we have DC link voltage constant, development of V by F control will be difficult. It is not impossible, but it is difficult. So another very popularly used most of the time arrangement is we will separate these two. So we will do between panel and DC link, we will connect one more DC-DC converter. Normally boost converter is utilized. So all of this DC-DC converter is to do MPPT. So the voltage of the panel will be adjusted. Voltage of the panel will be adjusted by this DC-DC converter. Inverter now it is reduced to just with the available DC link, which will be constant now. Available DC link, you will have to run the fan with a variable frequency. So once again, electrical source is variable. So PV power here is variable. So motor is to operate with a variable speed. Variable water discharge will be the end outcome. Development will be easy. So separate DC-DC converter for MPPT. So sense panel voltage, panel current, decide the duty ratio of your boost converter. So always you will be at the peak of PV curve. That energy is going, so that energy will be dumped into DC link. How the control of inverter will be developed? So we will try to maintain DC voltage to a constant value. So one outer loop, DC link voltage we will try to maintain constant. Now we know that how much power is coming. So proportional to that, we will have to adjust the frequency of motor. Then only equilibrium can happen. So capacitor should not discharge, or it should not overcharge. So the frequency should be, or motor speed should be adjusted, pump speed should be adjusted in such a way that a motor power will be matched with available PV power. Then equilibrium between PV power and motor and output can happen. Okay. So the relation between power is in a cube root proportion. So some frequency we will estimate proportional to cube root. So pump constant time cube root of available power. That way we can judge, and then this incremental frequency to maintain DC link to a constant value can be added with that. So that is how what frequency you will run the inverter can be judged, and then V by F control, normal V by F control can be applied. Okay. So this case also required, we will be having variable water discharge, but now DC link of inverter is constant. Result V by F development will be easy as compared to previous case, but variable water discharge will be there in this case also. So these are all standalone pump. Motor speed of the motor is changing. Is the only load which can accept this, that variable energy is coming, and anything what you can do with available electricity you do. Like domestic, if so somebody will say that variable energy is coming, few fan and few tube light will work at their own decision, so it is not accepted. So irrigation is the only load where this variable standalone arrangement will be helpful. So what we need to do to make this reliable, to make pump filling time to a constant value. The water discharge by the pump is not constant. We cannot assure that overnight the farm will be filled with the water or it will happen. So the idea is you take some other source. You will have to give constant power to the motor. So some power panels are giving power. We should have some source to which that power should be supplied. Then constant electrical energy we are giving to the motor. That make our induction motor to operate at speed, and that is how a water discharge rate can be controlled. So possibilities are, you can use batteries for affairs. After a few years replacement is required, so very heavy cost. The period is not available. In areas they use high power plant. So heavy energy is coming from the lower reservoir where water can be the motor will be operated as a pump, and water can be filled to the higher reservoir. Whenever we require, so potential form that energy will be stored via stored energy on water in a higher place reservoir. Storage, these are the two options, either hydropower plant or batteries. The good source is, if you have our normal grid available at that instant of time, we can connect this grid with solar, and whatever deficient energy we required from the grid, that can be extracted. Okay. So in literature, three arrangements are more popular for interfacing this. Now there are two sources. Through boost converter, it is feeding power to the DC link. So are through boost converter power to the DC link. The second is simple diode rectifier. So 4 diode, 8 diode, 6 diode arrangement based on single phase or 3 phase AC grid. Once again, it is connected with DC link. Okay. Now here, a motor, we will give a command to run at rated speed. So whatever be the rated frequency of your motor, accordingly V by F control will be applied, and motor will always run at constant RPM. Okay. Now, possibilities, sun power is less, and DC link capacitor will try to discharge. Is the case? Then from grid, the diode rectifier will draw the current, and once again it will bring a capacitor to the peak of your line voltage. Okay. Okay. And other case, so practically it will be like this. So suppose single phase diode rectifier, boost converter, and our DC link intermedia to integrate these two sources together. Okay. And motor will get constant energy supplied via and unlimited source. This is our normal generation. Okay. Some control scheme to control this. Okay. Now here, the only possibility which will create problem is we do not want to run the pump. PV energy is available. Then what will happen? There is no other load which can consume this energy. So it result into, I said, electrolyte capacitor is equivalent to tank. So we are just filling the tank and outlet tap is closed. Consumption is not there. So as a result, at some point overflow will happen. So our electrolyte capacitor will get damaged because of the overcharging. Okay. If that is the case. So this arrangement, the moment we should keep monitoring DC link voltage, and in a situation where pumping is not required and sun power is available, we need to disconnect. We should remove this PV panel from the arrangement. Otherwise, failure of DC link capacitor will be observed. Okay. The second problem, what we have with normal rectifier is the current drawn by diode rectifier is not signed. So supply current, utility would not like this. So supply current will not be sinusoidal. So these are the two plus minus of this arrangement. We need to avoid capacitor overcharging situation, that is under light load situation or situation. And second, supply current quality will not be proper. To do this, the second solution is use diode rectifier with PFC converter. PFC, few of you may be knowing, that is power factor controller. So nothing but one more boost converter. We connect boost converter at the output of diode rectifier, and then boost converter rectifier electrolyte capacitor. Then the supply current, what it will do is the supply current, it will make sinusoidal. That power quality problem of drawing non-sine current will go. The second problem of light load situation. Over here also diode cannot allow current to go back to the source. So this converter, that is boost PFC, also unidirectional. You can only take power from AC grid. So once again, under light loaded situation, you must remove your panel Otherwise, a DC link capacitor will get damaged. Okay. Link overcharging will be an issue in this arrangement also. Power will not be the issue. Sine current it is drawing. Now, third universal arrangement is if you replace the diode rectifier with IGBT based rectifier, it is bidirectional. So collector to emitter current can also flow, and because of that anti-parallel diode, emitter to collector also current can flow. So DC link and AC grid, bidirectional exchange of energy can happen. There is no need to disconnect your panel. Several possibilities, like if we have a sufficient load, supplying deficient power we will take from grid. Major source is solar panels. All power what we require, that we will draw from grid. Run inverter with a constant frequency, so at a higher speed the pump will run, and accordingly the highest possible water discharge rate will be there, and in a stipulated time period the farm will be filled with the water. Okay. The possibility is light loaded situation where pumping, suppose extreme situation, pumping is not required, pump is switched off. This solar energy is coming. So we will try to overcharge the capacitor, but because of this PWM rectifier, directional rectifier, that current can go reverse also. So now the way we are feeding at our rooftop, energy is going back inside the grid, and the load can utilize this. Okay, it will not go back to the original generator inside, but it's going inside the grid, and the place where load is available, that will utilize this electrical energy. So this is a universal arrangement where supply quality, so pure sine current also it will draw, current also it will draw. All the situations are handled. Okay. Is required for very limited time period. So if you have solar panel installed there, and for monsoon we don't require, how many times in one crop period farmer will fill the farm? So 2-3 times. Irrigation is required for very limited time period. So utilization of solar panel will be very less if you just restrict the use of panel to run the pump. So this is good arrangement where panels are always connected, and whatever it will generate, it will go to the grid. So utilization of solar panels will be better in this case as compared to previous arrangement where we need to disconnect them because those diodes were not allowing energy to go back to the AC system. Okay. So this is a universal arrangement. So boost converter will do MPPT. So we will sense panel voltage, panel current, some duty ratio of lower boost converter, extract the maximum power from panel. Capacitor is a media. So these two sources will be integrated. Whatever power will come from solar panel as well as grid, it will get accumulated at DC electrolyte capacitor. Whenever we run the motor, we'll make sure that DC voltage capacitor is maintained to a constant value. You can run the pump at a constant speed, and never the DC link capacitor will be discharged. This is the third arrangement to integrate a normal grid with PV. So these are the three possibility to which grid can be interfaced. So diode rectifier based system, PFC based system, and this voltage source converter or IGBT based rectifier based system. Grid can be connected with solar panels. So question at this instant of time. Any questions? participants? कुछ क्या है, कुछ भी बोलना नहीं है. Fine. These are all known information, or
Sir, there is a question in a chat box.
can anybody read?
How to calculate DC link capacitor value?
So there is a standard formula. So the designing parameter is the switching frequency of your inverter and how much percentage ripple you will allow. So this value you substitute there. Whatever next I will be presenting my article, over there you can have that formula included in this presentation. So suppose 10 kilohertz you are working, so capacitor will be utilized 1 by 10 kilohertz is 100 microsecond only. Say that 2% ripple is okay, so small rise and fall of that capacitor value will not affect my inverter performance. So this way, what storage we require, so the half CV square, how much energy it will have to store for that 100 microsecond can be calculated. This is known, corresponding microfarad can be calculated. So that formula is frequency and your ripple voltage allowed. Is it okay?
It's okay, sir.
So next topic is, so this much discussion. Now this title I have changed from blue to red. Okay. So the issues in this solar water pumping system. Talking about diesel pump or electrical pump, only solar water pump. What are the issues?
So one question is
Yes.
there, sir.
Please.
If
VSC based
system
system is not
filling
filling to grid,
what
what happens?
I'm not getting. There was
If
some
VSC
echo.
based system, if VSC based system not feeding to grid, what happens?
Feeding to grid, then the same thing what was there in previous two cases, overcharging of DC link capacitor will happen. And these two tap, this solar and grid, these are the two tap which is feeding the tank. You must have outlet. The tank level can be maintained to a constant value. So capacitor voltage can be maintained to a constant value provided whatever energy is coming from two source is getting utilized by your pump. If you are not able to utilize, what you should do? So it should go back to the source. So there should be a provision where it will go back to the grid, then only it will happen. So in a case that VSC based rectifier will not be able to feed the energy inside the grid, inside the grid does not mean that it will go in our thermal power plant. Ultimately, we are giving inside the grid means the thermal power plant generation will decrease. So adjacent load, rooftop, our neighbor is utilizing our energy because we are not utilizing. So same thing we will have to establish here.
Yes. One question from Atul Gandhi. Can you transfer direct energy to load without battery or grid?
First arrangement is direct transfer only.
Yes. Yes, correct.
Is direct transfer only.
Mm-hmm.
Have 6 IGBTs in between panel. So just the word they use is standalone arrangement. So we don't have any interconnection. So just panel, some electronics and pump. So whatever electrical energy is available from panel, accordingly the pump will run. And water discharge you will get.
Okay. Okay, thank you, sir. So we can proceed for the next part, sir.
Okay. So read title, issues in solar water pumping system. So first thing is arrangement provide variable water discharge. So फार्मर को चालू करके भूल जाना है, कब फिलअप होगा वो देखते रहना है, not practically. Sun availability is limited time period. As per our ambient, we can say 8 to 4. Expect solar energy or electrical energy from solar only for 8 to 4. So 16 hours, we will not be having water discharge. Grid integration, if we consider, then if you have a unidirectional converter, maybe diode rectifier or PFC converter, constant water discharge is possible. There will be a power quality problems. Okay. In integration period, it will create problem. So it not require pump or water is not required, pumping is not required. The capacitor overcharging is a major issue there. Integration with bidirectional, this VSC based converter, so that can assure constant water discharge, quality, power feedback to the grid, but negative side is those 6 semiconductor switch itself was a challenge. V by F control and sine PWM and all that, and more 4 IGBTs. So quite complex control where DC voltage will be maintained to a constant value and bidirectional flow of current you will have to control. So total 6 plus 4, and if you take 3-phase AC, then 6 plus 6, total 12 IGBTs you will have to control. So number of switches and associated control is the only negative part. Technically, you have all possible solution with the last arrangement where 65 days during sun availability period, you can keep the system on and the generated solar power will be either utilized for pumping or it will go back to the grid. Now, another common problem while studying with Rajan, what we could understand is irrigation period is very small. Is in one crop period. 3 crop period also, if you consider, then monsoon, during monsoon it is redundant. We that rainwater only we utilize. So for a 5 HP pump, if I have a 5 HP inverter doing that job, what is the utilization? What is the utilization of that inverter? So it is very limited. So for 24 hours, if you consider 8 to 4, only for 8 hours sun energy is available. So 16 hours to do anything with that. And when we require irrigation, then only you are utilizing. And also the overall use of this electronic is very limited. Okay. Also, so night time, what that inverter can do, because sun is not available. So some other functionality, if you can club with this, because that electronics is available. So those IGBTs are available, gate pulses are available. Source itself is not available, so that remains ideal. So what I'm trying to highlight is it's a very large period or major period of, if you consider, this electronic remain ideal. We are not utilizing it. It is just for a small period of your year. It is in use. Okay. Something we can try to do around this. In our approach, the method was, if farmer that one more converter you will have to connect, and things will work. So it will not work out. So whatever we have tried to conceptualize, the idea was no extra power electronics interface we should add. Existing, maybe a single stage arrangement or 2-stage arrangement, whatever we are having, the same arrangement during this off period where irrigation is not required, when sun is not available, functionality we can establish. So from that angle, we have tried to do some research. These are the 4 articles. What 4 articles? First 2 are article. Third is patent. Also we have submitted. It is in evaluation phase. Recently he has published. This green one article we publish in IT. That work I will try to present to you. Okay. Everything will be around how to increase the utilization of pumping infrastructure. So during the off period where irrigation is not required, night period when sun is not available, so how to utilize that infrastructure will be the theme of all the study what we have made. So title is development of grid interactive inverter utilizing induction motor driven solar water pumping system. So there exists a solar water pumping system. Induction motor is there and 6-switch inverter for driving V by F control of induction motor is there. Okay. So for pumping purpose, it is okay. Whatever concept I explain you, to cube of the frequency and variable frequency, all those things will be okay. How to utilize this 6 semiconductor switch and motor, pumping is not required. That will be that grid interactive inverter. Okay. So what we proposed, so only that VSC converter, we require 6 more IGBTs and 3 interfacing reactors. Okay. So when pumping is not required, can we use the same IGBT, place the stator winding for as an inverter and VSC converter? From where to bring the filter reactors? And the idea came that use motor winding. Can we use motor winding as an inductor? Now, induction motor, we all know, a 3-phase alternating voltage given to 3 winding will produce rotating magnetic field. So a 120-degree phase shifted supply given to 3 winding will result into rotating magnetic field. So when you use the winding as a reactor, we will have to make sure that this rotating magnetic field should not be there. We would have to avoid this rotating magnetic field, which can be done 120-degree phase shifted supply not be given to these 3 windings. Okay. So what is done here is same inverter will be used as voltage source converter. Grid will be connected. Between the star point of our motor winding. So winding is inductor. So we want to construct this. From this, we want to construct this. So three-phase motor winding is 3 reactors connected in RYB phase. Three-phase inverter, which was connected with the stator. Now it will be used as a voltage source converter. So it will have to feed energy to this AC source. There is one transfer switch. So there will be off-grid period. Transfer switch will convert the operation from pumping to energy generation or grid connection. Okay. In this work, a grid interactive inverter was constructed utilizing the same IGBTs and 3 winding of the motor. Okay. Makes sense? Additional power electronics interface, same IGBTs, what is used for driving the motor, are working as a voltage source converter. Motor winding connected with some logic used as a reactor. Okay. This is a conventional arrangement, and this is what we propose, that you can construct inverter like this. You don't require any extra IGBT. You don't require any extra reactor. 8 pulse generation logic you will have to modify. expanded form, it will look like this. All three legs, the grid is single phase. So all three legs, we operated in interleaved configuration. So in each winding, in each winding, the current will be having same phase angle. 120-degree phase shift, if we give co-phasal current to all three windings, magnetic field will not be there, and torque produced by the motor will be zero. So, the motor windings will be used as a reactor. So there are three identical legs, and each leg IGBT will be operated in such a way that the current through the winding will be co-phasor. So there will be a 0-degree phase displacement between all three currents. IA, IB, IC are the three currents, and that will get accumulated, and the summation of these three current is IG. IA, IB and IC is not having that 120-degree phase displacement what normally we have in motor, but they will be co-phasal current. So the summation of these three current is my grid current. Okay, so this is how each winding is acting as a three reactor. So in single phase or line diagram, this is the two leg will be acting, and the motor winding reactor will be there. So three such legs, all are feeding current. This is how the overall current will go to the grid. Possible operation, so power is available, irrigation is required. So this transfer switch should be there in off position. What is the functionality done there? So maximum power point it will have to track, and that inverter, the activities are acting as an inverter, and it is driving the pump. PV2 motoring operation is happening. So irrigation is happening during this period. Okay. Possibility is sun power is available, but irrigation is not required. So now what we will do, that transfer switch that is between the star point of our motor and midpoint of capacitor, we will close. So, maximum power we are tracking, but now that inverter is acting as a voltage source converter. Windings are acting as a current filters or reactors. Torque produced by the motor will be zero by forcing all current, all phase current to a co-phasor. PV to grid operation will happen. So power will go from PV to grid. So MPPT will happen. So adding any extra power electronics interface, that energy is going to the grid. Okay. Possibilities are, so this will also not complete the cycle, because first and second is only between 8 to 4. Can we do something from 4 to morning 8? So we can construct a STTCOM, that is reactive power compensator. 90-degree phase displaced current can generate without solar panel. So normal STTCOM, we will have this pure DC link voltage, and then we can generate a 90-degree lagging leading current. That is what we say reactive current. Situation, sun is not available. That is evening 4 to morning 8. Okay. Require irrigation, or you may not require irrigation. Okay. What all we can do is power you can generate. So this is connected with grid. This IG is not in phase with VG, but quadrature to VG. So this is how the reactive power requirement somewhere else in the grid support. So suppose far place in the farm, the water voltage magnitude will fall to a very low value. So increasing by providing a capacitive at such remote place, the voltage profile can be improved. So you can increase the magnitude of voltage by providing a reactive power over there. So the additional functionality added here is STTCOM functionality. So there are 4 operations. Water, so pumping operation, PV to grid, so active power transfer to the grid. So this will happen only when sun power is available. In absence of sun power, a STTCOM operation. So that is all what we implemented here. Any question related to this idea?
नहीं है।
Okay, I'll go
No,
ahead.
yes, sir. You can proceed, sir.
Okay, so control blocks. So grid voltage, grid current, you will have to sense. Then those who are working in the field, they will appreciate. We will require to sense the grid voltage and grid frequency and grid angle. Then the inverter we can run in synchronism with grid, and bidirectional power flow we can establish. DQ based control system where voltage and current will be converted into VD, VQ, IDIQ. With grid angle, we can construct two-based controllers. So one outer PI controller for DC voltage control and two inner ID and IQ current control. So that way, a modulating signal for inverter can be generated. And it is a separate part. Some Perturban observe MPPT algorithm we have utilized here. That is not the focus here, but MPPT should happen. So voltage, PV current sensing, maximum power point tracking, and then some duty ratio given to boost converter doing that MPPT part. Okay. So in PLL there are several methods. So we explored SOGI, second order generalized integrator, for finding two components. So we can take one voltage and two orthogonal components you can compute. Its frequency and position also you can compute. So complex mathematics. So this is the heart of the thing. So we implemented all this, then all this functionality are realized. So this is the picture of the setup. So 160 watt, 4 panels available, rooftop, and there exists one boost converter. Whatever controller I explained you yesterday, same controller we have utilized. Okay. Same inverter, whatever picture I have shown you, where semiconductor switch, sensors, everything is mounted inside. Sensor output is connected to the controller, and gate pulse generated by the controller is connected here. Okay. Induction motor, water pump is utilized over there. That is how this arrangement was constructed. So it is connected through induction motor. The specification of the arrangement. So 160 watt panel having short circuit 0.96 ampere and 43 volts of open circuit voltage. Standard test condition, the MPP point is 4.57 ampere and 35 volt. 4 such panels are connected in series. Maximum power is 4 into 160, 0.64 kilowatt or 640 watts of power is available. We're trying to run 1 HP motor with this, where motor nameplate is 400 volt, 1430 RPM, 4 pole, 50 Hertz motor. Capacitor. So DC link we try to maintain 300 volt, and the DC link capacitor voltage via those formulas calculated in the range of 4700 microfarad. 300 volt we cannot generate 415, so 230 volt will not be possible. So step up transformer is utilized. So 80 volt grid voltage is generated, and then 80 to 230 volt transformer is utilized to connect that to the real grid. And boost converter, so it is designed with 20 kilohertz frequency. Voltage source inverter, so IGBTs of motor inverter is switched at 5 kilohertz. Because of this lower frequency, the reactor is in the range of 10 millihenry, which is connected over here. Of outer voltage control loop, D current control loop and Q control loop we tune to these values. Some parameters through which the system was working. Now in terms of testing, so three major testing we represented for writing that article. So number one is performance of our PLL method, SOGI. So we are taking grid voltage. The SOGI block is dividing this into two orthogonal components. So V alpha, V beta. So V alpha will be in phase with Vg and V beta will be quadrature to V alpha. So there will be a 90-degree phase displacement between these two. Okay. Another thing we estimate through SOGI is angle theta. So the 0 to 360-degree variation of our cycle. So zero crossing is aligned with this and supply zero crossing 0 to 360, 0 to 360. So this is the angle theta estimated by PLL and frequency. So 50 Hertz frequency is estimated like this. Okay. Analyzing this theta is all the grid current. So this is actual grid current and it can also be converted into alpha beta components. So I alpha in phase with theta, VA and I beta. Performance, steady state performance of FLL, FLL will be like this. So input is one grid voltage and one grid current and outputs are this many. Two components of grid voltage, frequency of grid voltage and two components of current. Okay. Under dynamic situation, how this SOGI will behave. We tested it where grid voltage is suddenly reduced from 80 volt to then the reverse case where voltage is increased from 80 volt to 100 volt. So whenever there will be a sudden change in grid voltage, whether that PLL will be able to cope up. So that testing was done. So in an expanded form, so this portion expanded here. So theta, it keeps calculating proper theta and frequency while the voltage, grid voltage is dropping or grid voltage is increasing. Okay. Whenever there is a change of load, so suppose grid current is changing. So grid current from some high value to low value when it is going. Load to higher load when it is going. So in that period also whether alpha beta component of grid currents are calculated properly. So FLL is working properly or not. Under this variation that was also tested and presented in this article. The first testing. Now second testing is PV2 grid operation. Power going inside the grid. So this is the grid voltage, grid current. So if you compare this, and it is 180-degree out of phase with grid voltage. So that is the meaning power is going or current is going inside the grid. So whenever we have a 180-degree phase shift between voltage and current, it is active power going inside the grid. Okay. The voltage is maintained to a constant value while doing this. So these are the three-phase current. So three identical current. You can see that co-phasal current just to use motor winding as a reactor. So in all the winding, you have same phase angle currents are flowing. So phase angle of all three currents, IA, IB, and IC are same. This is the grid angle. So co-phasal current, our rotating magnetic field calculation, IA, IB, IC, if you substitute only omega t, omega t, omega t, then that rotating magnetic field will not be there. Okay. So that is how the torque produced by the motor we can make zero, and objectively motor winding are acting as a reactor. Okay. So these are those IA, IB, IC are current flowing through three winding, which is of co-phasal nature. So PV2 grid operation, we wanted to vary the PV power. With the help of some extra student, few of the panels are shaded with some cloth. Okay, so power is dropping from 280 watt to 190 watt, and once again, so some change in a panel output was applied. Okay, and testing was under this situation also. The VDC is maintained to a constant value, and whatever, so the moment power has changed, grid current amplitude will change. So it will be adjusted to this new situation, and equilibrium will be there. Whatever is coming from the panel, same power is going inside the grid. Okay, so VDC maintained to a constant value, and power, a variable power, 240 watt, 200 watt, any variation what is happening practically is going inside the grid. Now the third part, so reactive power operation. In night period where panels are not giving any power, so quadrature current. So if this is a grid voltage, I can have a 90-degree leading current, I have a 90-degree lagging current. So quadrature current, this arrangement can generate. So DC link capacitor, 6 IGBT, and 3 reactors. Utilizing this, a quadrature current we can generate. Okay. Leading reactive energy, this arrangement will provide. VDC will be maintained to a constant value, and IG will be leading to VG by an angle of 90 degrees. Here, VDC is into a constant value, but current IG is lagging behind voltage VG by an angle of 90 degrees. Okay. So this way, this result, and the right hand side is our motor current. So motor current should always be co-phasor. So it will not matter for motor winding whether lagging current or leading current. All should have same phase angle. Then the motor net torque produced inside the motor will be zero. Okay. So co-phasor current here, and here lagging current is flowing through the motor. So this is the testing of STTCOM operation. First, A and B are leading power supply, and C and D during lagging reactive power supply. Dynamic performance, there will be a sudden change of load, and then whether that reactive power supply will be continued or not. So sudden fall of current is applied here. So reactive power, instead of some magnitude reactive power, if you are saying less reactive power you supply, so that case also the lagging and leading current. So one case is lagging VAR generation, and another case is leading VAR generation, both operations. So this is dynamic performance. So whenever reactive power requirement is changing from high value to low value or low value to high value, how the system will respond to it, and whether it will be able to fulfill that reactive power requirement or not, that was tested. The different result we documented in that article. It is available on net. Okay. You can download it, and complete detail of system design was also provided in that article. So in summary, interactive solar water pump system is proposed. The single phase grid is interface with the 3-phase solar water pump to its integrated PV inverter functionality. So what is this research is how to use existing inverter and motor winding as a PV inverter. In term, the utilization of motor winding, motor drive inverter and motor is increased compared to grid supported solar water pump. The function as integrated inverter and winding as a filter inductor. Reactive power exchange can be established. Okay, utilization of this infrastructure will increase. Very important. Currents are forced to be identical in magnitude. And synchronously switching 3 legs of our voltage source inverter. So that will give us a net torque produced by the motor to a value 0. The only limitation of this arrangement is and this PV to grid operations are not possible simultaneously. So the transfer switch is there. So you operate for pumping purpose or you operate for grid purpose. So those two operations are possible simultaneously. But as I commented, we have a very large period. We don't require irrigation. So during that way, logically it is okay. Over there, this infrastructure you can utilize a PV inverter. The effective utilization of solar water pump infrastructure increases significantly without adding extra. The major thing is without adding any extra power electronics interface. The period of solar water pump will reduce, and which will encourage farmers for. So it is also throughout year energy is also going inside the grid. So directional metering and other thing, if government will allow to a farmer water pump, their payback period will significantly increase, and it should encourage farmer to install a water pump having all these functions. Any questions related to this? The second hour or second part of my presentation, that some work we have done in Indian context.
Any question, participants? Do I have any query? Please ask. Sir, my question, Mulla sir. Yes. So
Yes.
you have mentioned some power quality issues with this our system. So which type of power quality problems are occurs or issues are occurs with this?
There are three interfaces for interfacing grid to existing water pump. One is you connect via diode rectifier. Another is you connect via PFC rectifier. The third is this VSC based rectifier. So power quality issue will come only in first case. So diode will draw non-linear current. So non-sine current we are drawing from the grid. So as a result, in terms of theory, current distortion factor will be very heavy. So your power factor will be less due to non-sine current drawing from the source.
Any improving power quality improving techniques used?
So this inherently PFC is doing that.
Yes.
Converter we can force current to follow the voltage and it should be sinusoidal. Yes. That problem is solved over there.
Thank you, sir. Thank you very much. So any question from participant side?
आज सोच के आया है कुछ भी नहीं पूछना.
Yes, sir. This is the lunch. I think lunch time.
Sir.
This is the lunch. I think.
Sir, can I ask?
Yes, please.
Can you elaborate?
Yes.
The
Can you please repeat? It was not audible.
The subsidies of the
not audible.
Repeat. Professor Javade, please repeat your question. Professor Javade, please repeat your question.
Sir, there is disturbance, lot of disturbance from your side. Can you please switch?
Can you please mute yourself? What is solar water pump subsidies given to the farm?
I could hear subsidiary given to farmers.
Farmer,
But what is the question? That is not
sir,
clear.
for the install pump to the farmer.
मेरा कट रहा है आवाज.
Details of what all subsidiaries are given?
Yes, sir. Yes,
Okay.
sir.
So there are two schemes. So some part I copy pasted. There is one document available at MNRE website. There are two schemes. One is if they have existing electrical pump, if they want to upgrade this to solar water pump, then some benefits in the purchase subsidy is given. Second is if they are making new installation, further this subsidiary is given. So these two schemes are running. They want to increase the number of solar water pumps and they want to upgrade existing electrical pump this solar water pumps. So both incentives are available from government. So
Okay.
is available the way we are having.
Sir, what is the percentage of
running at
subsidy?
this stage.
Sir, yes. What is the percentage of subsidy they are giving?
Figure I have the document, but I have not.
Around 50%, 70%.
Hello.
Government. That way, certain decrease will be there in that amount. I feel it will add incentive for this needs injected in the grid, then substantially it will help farmer to increase their income. It will also become serious. Instead of normal pumping, they will start getting some incentive. Active energy, their pumps are able to feed in the grid. Active energy, then more payback will come. At this stage, they will have to invest something. It is not like freely it will be available.
Okay, okay. Sir, I would like to ask one more question, if you don't mind.
Please.
Sir.
Discussion. I am not taking it as a question.
Okay, sir. Okay, sir. Sir, so many solar panel cleaning systems are available. For that purpose also we are getting the subsidy. We can utilize that subsidy.
No. Government is very clear. Even if you connect battery with this system, subsidiary will not be up.
Okay.
There are no incentive for that cleaning and other thing.
Okay, okay. And sir, for installation of this solar panels in the farm, there is a wastage of space. So whether we get benefit of that waste.
Why you are taking it as a wastage of space? You have to install water pump.
No,
Some
we want to
digging is
install
already
for
required.
हाँ सर, प्लीज कैरी ऑन.
क्या है
सर?
Yes. Okay. Any question? Do you have any question?
European countries में open.
Okay.
सर हमको पार्ट
Is my mic is not properly working, so not audible clearly.
Okay. Sir,
Okay, okay.
type of inverter module should we select? Should we select when we grid solar generation of energy?
What we should select?
Inverter.
Uh,
Suppose we want to generate the electricity from the solar panel. So,
Right.
suppose we want to convert that electricity into the DC that is stored in the inverter through the inverter or directly fed to the grid. So, shall we require the inverter, or which type of inverter should we prefer?
Grid interactive are available nowadays.
Okay.
Our household, whatever we are utilizing, that is one example. So in synchronism with grid, it can do bidirectional power flow control. So if you have
Okay.
more load, then it will draw from the grid, and if you have less load, then it will pump that energy back into the grid.
Okay, sir.
Is applicable for water pumping also. Same inverter will be useful there.
Okay.
Last few minutes.
Yes, sir. Is there any limitation from
That
the
limitation part is battery based systems are also available, and they don't provide subsidy on battery based system.
no, sir. My question is for buying the electricity from the individual.
So Gujarat, I know our household, we have a policy where per unit they are paying in the bill.
Okay.
So same thing, if they extend to farmers also, then it will encourage that some earning is happening through the solar water pumps also, because it remains ideal for a large period.
Okay, sir. Okay, sir. Thank you
We
so
don't
much, sir.
require irrigation continuously.
Yes, sir. Sir.
Okay.
Thank you very much, sir.
Hey, it's okay. Thank you.
Okay, thank you, thank you. Any other question?
Hello. Sir, I have one question.
Please.
Sir, what is the impact of change of crop pattern on the energy exchange with the grid?
It's complex thing. Yes. What is the impact of change of crop pattern?
With the energy exchange with the grid, on the energy exchange?
That you can always correlate. Na? So ultimately, it is driven by change of crop pattern. What water requirement will be there? If sugarcane, then something different. If it is a rice, then something different. That is what you are asking.
Yes, sir.
So if you know the relation between crop pattern and water requirement, then you can always correlate that further with the energy what the solar panel is generating, how much how many units they will be able to pump into the grid and all. So
Yes.
agriculture side, that should be clear. What are the pumping requirement or irrigation requirement for different crops? Then it will be. I'm sure with a common sense we can correlate generation with how much energy will go for providing that water requirement and how much remaining energy will be pumped back to the grid.
Okay. Thank you, sir.
Okay.
Okay, thank you, sir. So
I will
I think
conclude. I will not abruptly end.
yes, sir.
Yesterday I said area is doing something in the laboratory. All these things working means we can always have PPT and good presentation or animation, but the same course we normally teach where the student will implement SPWM inverter, MPPT, DC voltage control very selectively, we have said. We have developed a laboratory, what in introduction Pareshji said. So basic power electronics, our 4 converters, then our motor drive course. So all types of motors, starting from DC motor to complex switch reluctance motor. So we try to teach this course where some controller and some sensors and some semiconductor switches are given to you, and then we will take some concept, maybe sensorless control of PMSM motor, and around that how by doing that you can learn that. So those things we normally teach. Okay, some of you, if you find it interesting, and from student point of view also, they will have to do the project where really some concept what is known to them, how to realize. In that context, it can help. Last 1 year, our all SVNIT activity are updated regularly by our PhD scholars here. Infotech, this SSBT college, they have a close affiliation. Courses related to skill development like PCB designing if student want to learn, and programming in C language if somebody want to learn. Courses they are also offering. So you can take advantage of this. So with this I conclude. So in this presentation, I try to speak about importance of renewable source, solar energy and solar water pumping system in our Indian scenario. Different types of existing solar water pumps arrangement we have reviewed. Operation. So what are the issues in standalone mode? What are the issues with grid connected mode? That I elaborated. And one of our work that how integrated PV inverter can be developed without adding any extra power electronics interface with the existing solar water pumping system was shared with you. Okay, so thank you very much for your patience hearing, and you may keep interacting. Okay, for any work related to whatever we can help.
Yes. Sir, thank you very much, sir. Sir, shall we? Sir, thank you very much, sir.
Thank you.
Okay. Shall we conclude, sir?
I'm done.
Okay, okay. Any question from? Okay, okay. Any question from participant side? If you have any query, please ask. Okay.
Hello, sir. Sir, actually, I haven't gone through your complete presentation. I had my class, but one question is there, one doubt is there. Suppose the solar panel is not providing a sufficient power. Hello, am I audible, sir?
Yes, you are audible.
Suppose solar panels are not providing sufficient power, and at the DC link, naturally the voltage will be lower. And then in that case, how basically the motor will be rotating at a constant speed?
So that is what is the trick, no? Solar may be providing very less energy, but what we are doing is we are maintaining capacitor voltage to a constant value. So if less energy is coming, we will run the pump at a very slow speed. So that way we will try to match incoming power with motor power. Make sure that even with a lesser power coming from solar, your DC link will be maintained to a constant value. So,
but what will be the action for that?
I always try to give the analogy of our water tank. So if your inlet is giving you less water, and if your objective is to maintain water level to a constant in the tank, then outlet also you decrease.
Okay.
Once that capacitor will charge to some value, and then we will try to hold that. So it will always be maintained to that constant value, irrespective of whether high power is coming, intermediate power is coming, or large power is coming. Holding that capacitor to a constant value, and how it will be done? So by changing the RPM of your pump. So continuously keep readjusting RPM of your pump. Then even with a lesser power coming from PV also the arrangement will work. Will be less.
Yes, output will be less.
Will be less. So variable output
Yes.
will be there.
Thank you, sir. Thank you very much.
But
Oh.
participants, thank you.
Okay.
It was nice to
Okay.
interact with you. Thank you.
Sir, thank you very much, sir. So, I would like to thanks Dr. M.A. Mulla. You have find your time to deliver the lecture from your busy schedule. From the behalf of SSBT Engineering College and Electrical and Electronics Department, I would like to thanks, and you have shared your experience. You have explained this pump and different grid interactive solar water pump. Thank you very much. You have explained very nicely. And my thanks to all participants, your patience. And our next session will start at 2:30 with the same link. Okay. Thank you very much, everyone.
Yeah.
Thank you, Mulla sir. Once again, thank you for
Thank you.
giving us a lecture. Thank you. और कुछ